Coffee is one of the most widely consumed beverages in all of the world. But there aren't a lot of people who really know what it is and how it affects our bodies. How much do you really know about coffee? There are a variety of different types of coffee beans. Arabica beans are what most people think of when it comes to coffee, and they come from South America as well as West Africa. These beans are picked when they're green, and then they are sold to roasters who are local to their markets, mostly in Europe and North America. But how do these magical little beans affect us? Caffeine is the main thing that affects you and your brain in coffee, and it is a psychoactive drug and is actually highly addictive. Besides caffeine, however, there are several other active ingredients, as well as antioxidants, present in coffee. But today, we're going to focus mostly on that wake-me-up drug, because that's what most people use it for. Back in our brain, the structure of the caffeine molecule is very similar to a chemical in our brain called adenosine, which is responsible for making us feel sleepy. Caffeine also stops the chemical dopamine from being reabsorbed. This chemical is responsible for making us feel pleasurable and rewarded. Everybody knows there's nothing quite like a nice cup of joe in the morning, and this chemical, dopamine, explains why we love coffee so much. Let's pause for a second. Why don't we know that much about caffeine itself? We've used all different types of experiments, microscopic observations, and even electrical measuring devices on our bodies, but it's still extremely difficult to study microscopic molecules and how they affect us. In fact, many scientists don't really know much about what drugs do on a microscopic level, even those prescribed to you in a hospital or at the pharmacy. We just know what gets done, and that's all that really matters. There are a lot of myths surrounding coffee. Does coffee impact time perception? What about blood pressure? Does it improve memory? Let's start with memory, because that's the easy one. Researchers at Johns Hopkins University performed a study in which, basically, subjects studied several images and then ingested either caffeine or a placebo, and their recollection of the images was measured. The results? Caffeine may improve memory in young adults. Blood pressure, though, is a little harder to talk about. We know that right after you drink a cup of coffee, your arteries and veins constrict, and therefore your blood pressure rises. However, it is extremely hard to tell whether long-term coffee consumption causes an increase in blood pressure. There are so many other factors, called confounding variables, that get in the way of long-term studies. Variation in diets, exercise habits, and genetics of individuals creates huge issues in finding correlations between coffee and raised blood pressure, or for that matter, coffee and any general health-related topics. Maybe our real question should be, how much do we know about coffee? Before we talk about perception, we really need to answer this question. The answer is, we really don't know much. For many observed effects of caffeine, just like many other drugs, we don't know why they occur. Keeping that in mind, let's think about perception. Perception is defined as the way in which something is regarded, understood, or interpreted. Now, we can rephrase our general question. How does coffee change the way we understand or interpret information? First, let's talk specifically about time perception. There is a very important part of your brain called the suprachiasmatic nucleus, which is sometimes referred to as your brain's internal clock. It is located deep in the center of your brain. Reviews of current scientific literature reveal that this area of the brain may in fact be sensitive to the effects of stimulants. One stimulant drug we know that we're going to be very familiar with is caffeine. This provides a possible physiological mechanism that could be a link between drinking coffee and altered time perception. Although this link may seem promising, recent studies have not had the same luck with it. Studies have not been able to demonstrate altered time perception in subjects that ingest caffeine. However, before we dismiss it as an impossibility, we must consider the nature of the studies and possible flaws. Besides the fact that many of these studies did not properly control for caffeine tolerance in the individual subjects, they also used extremely limited ranges of dosing of the caffeine itself. This could have neglected to reach the minimum dosage necessary to see altered perception. Additionally, the nature of perception itself is extremely subjective, and the only quantitative means of measurement was asking subjects themselves how much time they perceived passing compared to how much time actually passed. These data collection methods are very susceptible to error. All in all, there's a lot of magic packed into these little beans, and I hope you've developed a satisfactory understanding and appreciation of their power.